everyone. Welcome back to SAT Math Question of the Day. Here we have question. Please read it, do try it, then pause the video, try it, come back, and we'll do it here. A circle has been divided into 3 non-overlapping regions, 1, 2, and 3. The area of region 1 is 4 pi square centimeters. The area of region 2 is 12 pi square centimeters, and the region of area 3 is 16 pi centimeters. Okay, if a point on the circle is selected at random, what is the probability of selecting a point that does not lie in region 2? Express your answer as a decimal or fraction. So you've got 1, maybe a picture would be helpful. 1, 2, 3. Now hold on, let's do this carefully. This is 4 pi. We'll leave the units off. This is 12 pi. Got to be careful here. And this is 16 pi. What is the probability that it does not lie in region 2, which means 1 and 3? So that's 4 pi plus 16 pi divided by the total. And the total is 4 pi plus 16 pi plus 12 pi. And that's the answer. So that's the basic definition of probability. The probability of the number of ways, or basically the area that they wanted, that they're selecting, that they want to see what they want, like the chosen area. We'll say that the chosen area, 1 and 3. Divided by the total area, which is the total area. And that's it. So that's the answer. Then we have to do it. So this is 20 pi, and this is 32 pi. So the pi's cancel. And now we have to simplify that. They want it as a decimal. So if you're lazy, you could just hit it with the calculator. 20, first you turn the calculator on. 20 divided by 32 is 0.625. That's also 5/8. So it's a calculated question. So you could just do that, or 10 over 16, or 5/8. It's faster, actually, just to do it this way and not use the calculator. Just keep reducing it and get it into a fraction. It's faster. It was faster. You notice it was faster. So what do you think, Seth? You're sort of, you know a lot more probability than I do.
Yes,
it's true. You do know.
I agree with your conclusion. I agree with your analysis.
Okay.
The principal probability applied here is that the probability of picking a point in a region, in this example, is proportional to the area of the region. So the assumption is that all points within the same region are picked with equal probability when a point in the region is picked, and all the points in the circle have equal probability of being picked.
Yep.
Now, there are subtle measure theoretic issues. There are an infinite number of points in the circle. And so the probability of picking any one of them is 0. But but picking a point, it will be either in one of 3 regions, or what if it's on the boundary? Well, measure theoretically, the probability of picking a point on the boundary of an ordinary smooth region is 0. So there's a lot of subtlety involving probability, where there are infinite sample spaces. But this question basically simplifies away any of those issues.
Right. Plus, it's at the high school level.
It's the high school level and the SAT.
Right. So then one would pencil in or whatever you do with the SAT, either 5/8 or 0.625. So, what are our four questions? We'll start with the first question, the newest question we got about a week ago. Is there a pattern to this question that would help you do it fast? Is there a particular pattern unique to this particular question? Not really. No.
Well, all the areas are integer multiples of pi.
True.
So when you do the arithmetic, you could calculate with the coefficients and not be concerned with the value of pi at all.
Right. Yeah. That's true.
And
That's
in
true.
your calculation, the pi in the numerator and the denominator cancel.
I see. So if you saw that ahead of time, you really didn't have to waste your time writing pi.
Yeah.
Okay. So
and indeed, you did not evaluate the numerator and the denominator by pulling out the numerical value of pi.
Right. Of course not. Right.
An approximate numerical value, and if you did, it would cancel.
Right.
Yeah.
The question about whether you start with the guess doesn't apply. It's not a multiple choice question. Calculator, right? I mean, it could help if you want to do that or not. Does this problem differ from a school test? Not really. You can have this question be tested in school. Notice that they are also, you have to read it really carefully. A point that does not lie in region 2. So if you don't see the word not, then you have a problem with this question. Okay?
Yeah. One little word makes a difference.
That's right. This little word here makes a difference. Now, they probably did that on purpose to make sure that you are reading the question, which emphasizes again the ultra importance of reading a question, which, of course, I sometimes have a problem. So, I'm particularly sensitive to that. But still, no matter how hard you read the question, that's why it's very hard to get exactly an 800 on the test. Okay, and the main idea, what are they trying to test, if you know? I guess just the basic calculation of a very, very basic probability question. Or not the calculation, but the concept.
The idea of a probability is about a process of picking a point within a circle and affected by and the properties of whether the point is picked within one region or another region or a third region.
Yeah, but that's more specific. But in general, they want to know if you understand how to set up a basic probability question. The choices.
Well, this is often most probability. The probability questions we've seen most in SAT involve discrete sample spaces,
right?
Where the probability where there's equal probability for picking an element out of a finite set.
Yeah.
Right. So therefore the probability of picking an element in one of the finite subsets is proportional to the number of elements in it.
Yeah.
As here, you need to recognize that in this context, you replace the concept of number as the size of a set with area.
Yeah.
As the size of a set.
I mean, to a certain extent, it's common sense. And it is. I mean, you're talking about a dartboard. Or an arrow thing. You shoot arrows, and you have a circle here, a circle here, a circle here. Or really, to make it simpler, forget the circle because we're not that great at archery. But you have a thing like this, and what's the problem? Everything's cut in half, right? These are two equal halves. what's the probability of getting it into this half? It's obviously a half. No, if you get it in at all, right? If you get
No,
it in at all.
the thing is with a dartboard or an archery target, you cannot assume, and you should, and it is not true that the setup makes the probability of hitting a given spot proportional of hitting a given air region is proportional to the area. It's because when you aim a dart or an arrow, you try to get it as close as possible to the center.
Right.
So
okay,
it's not an so it's not a realistic model.
No. But the specific question would be that if you have a dartboard and or an archery thing, and assuming it does hit it, the probability of it hitting on this side,
you're assuming that the dart or arrow is shot randomly.
No,
and then assuming that's and then conditional upon that actually hits it, and then the assumption therefore is that any region is the same probability as any other region of the same area, uniform probability.
You didn't listen to my question. My question is simply, what's the probability of it hitting on this half? Because you're right, it's a larger probability hitting it on the outer edges, because if you're aiming here, then there's more probability here. But if you cut it just in half,
you're not aiming here.
Okay, forget it. Let's say you don't aim.
It's to assume it's the probability is there is half. So that's a problem with unusual symmetry.
That's what I mean. That's what exactly I'm talking about. I'm talking about
the
this
left half versus the right
problem.
half.
Right, exactly. No, I'm just saying it's common sense. It's just common sense that the probability of hitting at a certain spot in this problem, it's half of the total thing. It's just common sense. So to a certain extent, applying just common sense to this problem works. Now, that's rare in sometimes that doesn't work in probability. Intuition and common sense very often completely fail in a probability question. So, but in this one, it happened to be right. So, okay, so I guess we're done.
Well, again, I think what I want to say is that throwing darts or shooting arrows at a circle is not a model for this problem.
Right. That's right. That's why I'm getting rid of it. That's right. You're right. That's right. Yeah, because that's basically saying it's more likely you're going to hit on the outer than on the inner, or you're going to hit on the inner because you're aiming on the inner.
It's more likely to hit on the inner because you're aiming at the inner.
Assumes you're good at archery. But okay. Right. Yeah, that's right. Yeah. Okay.
And therefore, the probability of hitting a given area near the center is more than the probability of hitting the same area of a region that's further away from the center.
Right. Okay. Yeah. At least you hope so. Okay, so I think we're done for today, right?
Yeah.
I think we're done. Okay, everyone, have a great day. I'm Joel. I do have a PhD in mechanical engineering. My brother Seth is a PhD in math. We try to meet every 5 days a week, Monday through Friday, to go over a particular SAT math question. This is from the 2023 non-digital SAT, October 2023 non-digital SAT. And we're here basically to go over different approaches on how to do the problems. In terms of studying, try to do as many Blue Book questions as you can. Now the SAT is digital in the United States for high school students. So just practice. If you're weak on a particular subject, go to the Khan Academy SAT practice course. It's sanctioned by the College Board, and they have about 20, 30 questions on each topic to sharpen your skills on any one particular topic and learn from your mistakes and try to look at the problems in different ways, like we do. so you can be ready for basically anything they throw at you. Okay, and if you have, please give us comments on the videos. We take our comments, all the comments, very seriously. And if you have any SAT math questions, you can please email them to us at satmathquestionoftheday@gmail.com. Oh, okay, that's it, right? Okay,
Bye-bye.
well, hope to see you tomorrow. Bye-bye.